This is section 2.2, and this is trig functions of non-acute angles. So 2.1 we covered acute angles, and now we're going to have the non-acute angles. So every angle has a reference angle that we can refer to get information. So the reference angle for theta is theta prime. It's a positive angle made by the terminal side of the angle in the x-axis. In other words, here's a better reference. So here, this blue is theta. This angle in here, because you always go to the x-axis, this is theta prime, and we can tell that's an acute angle. This is not. So there's a rule for how to find the theta. Reference for 120 is 60, and that means all the cosine, sine, everything that holds for 60 is the same for 120, except perhaps negatives and positives. So here's the rules. In quadrant 1, theta prime is the same as theta because they're all acute there anyway. In quadrant 2, you subtract the theta from 180. In quadrant 3, it's theta plus 180. Did I have that wrong? So for quadrant 3, it's 180 plus theta. So here it's 180 minus whatever that is. Down here it would be 180 plus theta. And then quadrant 4 is 360 minus theta because you'd be right here. So that, remembering that, then all our problems are going to be working probably with reference angles. So let's go look at those. All right, so the first one says find the reference angle for the following angle, 127. So just to get a visual, and we're not going to do it every time, but 127 is somewhere over here. And so we said that was 180 minus that angle. So the reference angle for that would be 53. Find the reference angle for the following. So negative 116, there's 90. So we're somewhere over here. So it's 180 plus negative 116, and that would be 64. Okay. All right, find the reference angle for 725. Well, we know that 720 is 2 times all the way around. So if we were drawing it, you'd go around once, that's 360, then you're at 720. So 725 is right there. 725 minus the 720, 5 degrees will be our reference angle. Okay? This one has us complete the reference, this table with exact values. So here's what I want you to think about. Theta is 120. What did we say the reference for that was? It's 60 degrees. Well, we're beginning to realize that we memorize 60 and 30 and 45. And once we know those, we can get these. So we know tan is square root of 3. We know cotan is square root of 3 over 3. And we know cosecant is 2 square roots of 3 over 3 after we do the rationalization. But then what we have to remember is that you're in quadrant 2. And in quadrant 2, sine is positive and cosecant is positive. The rest are negative. So you have to make sure that you put those negatives in the right place. So you can get the angle parts, the trig functions, but we have to remember the SIG ends. All right, number 5. Sine squared 210 plus cosine squared 210. What is the reference for 210? Till it's easy in your head, here's 180 and here's 210. So that's where you are. 210 minus 180 gives you 30. All right? So we're using 30 as our reference angle, and the sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. You plug those in. Half squared is 1/4. When you square this, you get 3/4. You add those together, you get 4/4. That's equal to 1. Let's do the same thing with this one. Sine squared 240 minus cosine squared 180 plus tan squared 60. Well, 60 we know, and the reference for 240 is 60. 180 plus 60 gives us 240. So sine of 60 is that. Cosine of 180 is a quadrantal, -1. Tan of 60 is square root of 3. So we can put those in, and so we're squaring everything. This was a negative. It'll end up being positive inside there. So we got 3/4 minus 1 plus 3. That's equal to 2 3/4. Change it to a fraction. So improper fraction would be 11/4. All right, let's look at number 7. Oops, went too far. The value of 390 is it positive or negative? It's positive because 390 is in quadrant 1. Let's think about that. If we went all the way around, we're here because it's 30 more, and it's 30 more than 360, and the exact value of that is square root of 3/2. Cosine 30 is square root of 3/2, and it's a positive value because you're in quadrant 1 for cosine. So there's a lot of things to think about in these. You want to find out what angle is the reference angle, what is its trig value, and then which quadrant you are in. All right, tan of -150. Let's see, -150, we're going to be here. Okay, we're going to be right there. So we're in quadrant 3. The reference angle would be 30 degrees because you're 30 degrees away from the x-axis. Tan of 30 is square root of 3/3. All right, and you're in the third quadrant, so tan is positive. Find all the values of theta in the interval 0 to 360 that have a sign that is square root of 3/2. So if you have your chart and you're looking at it, or you've just really started to memorize it, you would know that the angle that has sign of square root of 3/2 is 60. Now, where is it positive? Because this is positive. It's quadrant 1 and quadrant 2. So in quadrant 1, it's 60. In quadrant 2, it's 120. That has a reference of 60. Number 9, same interval, sine theta is -1/2. Well, 30 has a 1/2. It is negative in quadrant 3 and 4. So in quadrant 3, you add 180 and 30, you get 210. And then in quadrant 4, it's 360 minus 30, you'll get 330. 11 is the same way. Where is sine +1/2? That's in quadrant 1 and quadrant 2, you get 30 and 150. 12, secant of negative square root of 2. Well, secant is 1/cosine. And the theta that has cosine of square root of 2/2. So if we divide this, if we say what is 1/square root of 2 and you rationalize it, you get square root of 2/2. The theta that has that as its cosine is 45 degrees. It's negative in quadrant 2 and quadrant 3 because cosine's positive in 1 and 4. So in quadrant 2, it is 180 minus 45, so that'd be 135. And in quadrant 3, it's 180 plus 45, so it'd be 225. 13, sine is negative square root of 2/2. We know that that's a 45-degree angle. Where is it negative? Where's sine negative? Quadrant 3, quadrant 4. So we get 225 and 315. You're saying 180 plus 45, 360 minus 45. For what angles is cosine theta equal to sine theta true? We talked about that. 45 degrees has the same sine and cosine. and it's in quadrant 1 and 2 where it's positive. I mean quadrant 1 and 3, so 45 degrees and 225. And that is our problem set for reference angles.